All right, so the first thing we got to talk about is continuous functions versus discrete functions. Okay, so first up, let's talk about a discrete function. It's made up of distinct points. Okay, so for an example with a discrete function, in that one example that we did on the eggs in a carton, you had whole numbers of eggs in there. So discrete functions usually deal with something that comes in whole numbers. All right, so this could be like you go to the grocery store and the number of items in your cart. All right, so if you made a graph of that, you'd have time on your x-axis, you'd have number of items on the y. So you'd start off at 0, 0. You're putting items in your cart at a pretty quick clip here. But yeah, it would keep increasing. You'd have 1 item, then 2 items, then 3 items, then 4 items, then 5 items, then 6 items, then 7, then 8, then 9, then 10. All right, but it would not be a continuous function because you couldn't have 8.1 items or 8.2 items or 8.3 items, stuff like that. So you're not hitting any decimals in between there. That's kind of like to think of those discrete functions is that, it's like whole numbers that you're always dealing with. Or I could say the number of students in the classroom. Like if I had a total of 12 students in my class, if I made a graph of the people entering the room, it would be a discrete graph. There would be 1 person in the room, then there'd be 2, then there'd be 3. There would never be like 3.1, 3.2, that kind of thing. And then the other type is a continuous function. All right, and that is made up of a continuous line or curve. All right, and this usually deals with when you can have decimals. Okay, so a good example would be time it takes me to run a 5K. So you're going to start off at 0, 0. So as time is increasing, so is your distance at a steady rate. Okay, because if you're running a 5K, you're going to go 1 kilometer, 1.1 kilometers, 1.2 kilometers, 1.3. It's a continuous graph. You're going to hit all those, decimals in between, or the height of a tree over time. It's not like a tree goes from 2 feet to 5 feet. It goes, 2.1 feet, 2.2 feet, 2.3 feet, and even smaller numbers than that. So that's the difference between your continuous and discrete graphs. All right, so just some important vocabulary then. All right, first up is domain. These are your input values to a function or your x values. So, if you hear me say x values, I mean the input, I mean the domain. Next up, you have the range. These are your output values and your y values. We're going to talk about a relation, and that's just is any set of xy pairs. And last up, a function, and that's a relation in which each x value is paired with exactly one y value. All right, so those are the main terms that we're going to be using to start this unit. Like I said, I'll be using those a lot. All right, so domain, range, relation, and function. All right, so first up, an example here. We talk about mapping diagrams. I could give you a function here. Oops, I hope it got on the screen there. So these mapping diagrams, nothing too crazy here. You're just going to take each x value, put it in the domain box, so 2, 3, 5, and 8, and you're going to map it, and then you're going to put your y values in the range, so 7, 9, 13, and 19. And then you're just going to go through each point. So 2, 7, 2 goes to 7, 3, 9, 5, 13, 8, 19. So again, each x value is mapped to one y value. This is a function. All right, when you're trying to determine if you have a function, you just want to make sure that your x values don't repeat. So x values do not repeat. All right, so let's do another one of those mapping diagrams. So again, you got to create these boxes for domain and range. Whoops, 1 second here. So again, your domain is your x values. All your x values are different here. You got -3, -2, -1, 0, 1, 2, and 3. Your range, though, you don't want to have any repeats here. Your range is just 0, 1, 4, and 9. So you had -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So this is still a function because none of these x values repeat. All your x's are different. Function because x values do not repeat. All right, so in this one, my domain, again, is my x's. So -5, -2, 0, 3, and 4. And the only y value I have is 8. So when you're trying to determine if you have a function or not, you're just looking at the x's. As long as all the x's are different, you're good. So this is a function. All right, they can all have the same y value, it's just the x's have to be different. And the last one we got to take a look at here. This one's not a function because all the fives repeat for your x's, not a function. All right, so last up, so if you're asked to evaluate a function, you're just substituting -8 in for x here. We can think of it as y or f of x. I mean, -24 minus 8 is -32, so that'd be the point -8, comma -32. I put -2 in, 3 times -2 minus 8, -6 minus 8 is -14. So -2, comma -14. 0, we get 3 times 0 minus 8. So 0 minus 8 is -8. So it'll be 0, comma -8. And last up with 4, 3 times 4 minus 8. It'll be 12 minus 8 is 4. So we got 4, 4. All right. Other types of functions you could have. I just want to go over an absolute value function. So absolute value function. Let's go with -5, -3, 0, 3, and 5. So absolute value of -5 plus 3 will end up being 5 plus 3 is 8, -3. Sorry, absolute value of -3 plus 3 is end up being 3 plus 3 is 6. Absolute value of 0 is 0. So I have 0 plus 3 is 3. So that's my next point is 0, comma 3. All right. So basics of functions, just the big thing, domain and range. Domain is your x values, your input values. Range is your y values, your outputs. Everything's a relation. To determine if you have a function or not, you just got to check, do my x values repeat? And the main reason is that both these are functions, like 3x minus 8 is a function. Okay. And if I put in like the same x value again, like if I put 4 in this again, I'm still going to get, 12 minus 8 is 4. I'm still going to get 4, 4. And it's the same point on the graph. So that's why your x values can't repeat. Okay. So that's really it for today. Again, just make sure those x values don't repeat.